Hello everyone. In this video we're going to talk about simplifying polynomial expressions by combining like terms. So for the do now, we're going to distribute and simplify that expression using what we learned in our previous class. So for the -6 in front of the parentheses here, I'm going to draw 3 little loops just to remind myself that, hey, I'm multiplying 3 times. Now each product I'm going to kind of write down separately. So -6 times 3x is going to be -18x. For the middle portion, which I'll change my color for so you can tell the difference, -6 times -5y. I'm treating that subtract 5y like a negative. So negative times a negative here, I'm actually going to put plus 30y. Notice in each case, like we talked about, the variable kind of glues on. There's nothing really to do with it, just you don't want to forget about it. And then the -6 times the plus 13. So this is going to remain minus. This is known as our constant. Our number on the end is going to be -78. Okay, that's our answer after distribution. Now the follow-up says evaluate the original expression and your simplified version for when x equals -4 and y equals 3. So what we're actually doing here is kind of showing that the original question and our answer, our distributed answer, are the same. This isn't a foolproof system, but this is a way of checking that they are equivalent. So what I'm doing first is just kind of writing them with those values in place. And ideally, we distributed, we didn't change anything, so this should still have the same value. You could type this into your calculator if you like. I'm just going to quickly go through it. In the parentheses for the what I have up top, we'll get -12 minus 15. That's going to be -27. Plus 13 is -14 times the -6 out front. So -6 times -14 is going to be positive 84. And hopefully we get the same thing for the bottom one. If we get something different, we probably messed up somewhere. Hopefully not. So that's going to be 72 plus 90 minus 78. That's going to be 162. And again, you could type this all into your calculator. And 162 minus 78 is going to be 84. Like I said, this isn't a foolproof system. Like we could have actually still made a mistake somewhere and they worked out. Maybe we just got lucky or something. But what we just showed is the original expression and what we wrote, the -18x plus 30y minus 78, are equivalent through checking by evaluating. All right, the notes for today are very simple. They're up top. To simplify expressions, we're first going to distribute / multiply. Like in other words, if you see something hanging outside a set of parentheses, distribute that first. Today's lesson, you can't do unless you've already taken care of that. You don't want to start combining things. We're going to see what combining like terms is all about, but you can't start doing that until you've kind of done the cleanup first, the first step of the cleanup, which is to distribute. Multiply what you can multiply, basically. Combining like terms is basically kind of grouping the things you can together by adding coefficients. So like in other words, if you see a 2x and a 5x floating around, just make them a 7x. So the key point, like terms have the same variable with the same exponent. So they have to have both of those things. So some examples of like terms, if you'd like to kind of copy a chart like this. So 7x and 8x are like terms. Notice they do have a different number in front. One has a 7 and one has an 8. That's known as the coefficient. That's fine. They do have the same variable, and it's really x to the first power. They're both x. That's fine. What's an example of not like terms or unlike terms? Let's use 7x and 8y. So what's different here? It's the same coefficients. It's the same numbers up front, but notice these are different variables. Like terms can also have no variables at all. It's one that people forget about, like constant terms. So like 14 and -3 are known as like terms. You might be saying, hold on, there's no variable there. Really, there is a variable raised to the 0 power. If you want to argue about it, that could be your excuse. An example of not like terms kind of similar to that, if we slap on an x to one of these and not the other, We can't say like a constant and something with a variable. Those are not like terms. Now, where does the exponent part come into play? Let's say we have 2y and negative, oops, let's make this squared, and negative 5y squared. So notice here, all of a sudden we're mixing exponents in, so the exponents have to match as well. So there's like a two-step system here. The variables have to match, and if there is an exponent, they have to match also. Unlike terms would be exponents that don't match. So you might be saying like, oh, they're so close, they both have a y, but the exponents do have to match. These would be unlike terms. Y squared and y, close, but they're not like terms. For not like terms, there's nothing you can do with them. There's not like a lesson tomorrow on what to do with not like terms. There's nothing you can do. We're going to learn today about what you can do with like terms. Basically this, I'll give you a little preview. You can combine them. So like if I saw 7x and 8x in a problem, in an expression, in an equation, I would make it 15x. If I saw 14 and minus 3 in a problem, expression, an equation, I would make it 11. So you kind of get the hint here of what's going on. When we combine like terms, 2y squared and minus 5y squared, we're just basically counting. We're adding the coefficients, we're adding the numbers in front, and keeping the variable part the same. So now that we've talked about what like terms are, let's try an expression where we're actually applying combining like terms. So we're like going to clean this up ourselves. So for 3x minus 4y plus 5x plus 6y, there's no multiplication here. And what I'm going to do is kind of identify my like terms. And there's a few ways you could do this. Obviously, you don't have to bust out like different colors to do this. Some people make different shapes around them. So like 3x and 5x, I'm going to combine those to say 8x. So what did I do there? First, I noticed they were like terms because they both have an x. And then I added the numbers in front. 3 and 5 is 8. You want to pay very, very close attention to the sign in front. If that was a minus 5x, that would change my answer, and I would instead have negative 2x. So you want to pay close attention to that. Sometimes when people start circling things and things like this, they cut it off. Now for the y portion, notice once again, I took the signs into consideration. I have minus 4y and plus 6y. So negative 4 plus 6 is going to give me positive plus 2y. What I did there was negative 4 plus 6. I kept the y the same. Now I can't take this one step further. I can't do this. You might really want to your first time of combining the terms, but we can't do that. We can't say like 10xy. You don't want to go combining crazy here. You can only combine like terms, and obviously 8x and 2y are not like terms. For the example on the right, I see distribution, so I have to take care of that first. I wouldn't want to start this by like circling the a and the 13a. So I got to clean it up first. I got to distribute. Copy everything else down. Don't try to like write your answer and look back at the original. You're going to end up like double counting something or forgetting something. All right. If you don't like the like circling and using different shapes, another strategy you can do is kind of like underlining. So you could start with like one underline. So 5 minus 13a, those are like terms, give me negative 8a. I see b's. Usually your constant goes on the end. If you're curious, like why am I going a and then b? We'll talk more about that when we talk about standard form. So for b, I'm putting two underlines. b minus 12b is going to be negative 12b. This way when I look back, I can kind of clearly see which one's which. And then 3 for my constants. I see 20 minus 7 is plus 13. And it's not always going to work out this conveniently. Obviously, like we're practicing combining like terms, so I kind of made these problems that a lot of things would be combining. But you might have a problem where you can only combine one thing, and everything else is kind of just left hanging and kept as is. So always look to see what and if you can combine anything in an expression. You want to clean it up, like we say in math, as much as possible, whether it be distribution or combining similar variables or just similar constants like the 20 and the minus 7 here. Very, very important. organizing these problems, whether it be using different shapes, using underlines, and always take into consideration the sign in front. Notice in each case here, I didn't do this. This is something that's common for new people with this lesson. Let me just erase. Pretend we were doing this one again. I know there's a plus sign, so it doesn't really end up mattering anyway, but someone does this. And then there was really a minus sign up front, and they're just looking at it as like 6y, and then they end up obviously making a mistake. So you want to pay attention not just to the number itself and get excited that you see a like term, something you could pair up, but you want to pay attention to the sign in front. All right, for this last problem, I want you guys to try this one first on your own. It's going to pop up right now. So let's see if what you typed in was correct. So I'm going to do the underlinings here. So I start with x. Do I see anything that matches up with x? Are there any like terms for 4x? Yeah, I see a minus 13x. 4 minus 13 is going to be negative 9. You could use a calculator if you're still a little shaky with integer rules. Obviously, you don't have to worry about the x part. Just simply type in 4 minus 13. Now I see y's as well. I see 9y and minus 4y. 9 minus 4 is positive 5. So I'm going to put a plus 5. If it was negative 5, I would have put subtract 5. And last but not least, I do see constants. I see a plus 3, and I see a plus 8, which is a plus 11. And my final answer is what's known as a trinomial. It has 3 terms in it. And we'll talk more about all of this vocab in our next lesson. But hopefully this helped with some of the basics about combining like terms. We're going to follow up with a day 2 of combining like terms with some more practice and some more complex examples. Thank you guys for watching, and let me know if you have any immediate questions regarding this topic. Take care.